Okay, Cassidy,
Here.
Alejandro,
Here.
Liliana, Lainey,
Here.
Romeo,
Here.
Brenda, Jasmine,
Here.
Jade, Valerie,
Here.
Edsel, Joel, Monique, Salvador,
Here.
Caitlin,
Here.
Kayla,
Here.
Romeo,
Here.
Paula, is that it? Oh, and Ricardo.
Here.
Okay, anybody did not call? Liliana, Edsel, Joel, Monique, and Paula. Okay. Okay, let's start working on chapter 11 today.
This meeting is being recorded.
Stop. 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 Because I updated. Okay, so let's go over chapter 11 here. Okay, chapter 11. Says, have you ever popped popcorn in a microwave? Think about what happens in terms of the rate at which the kernels pop. For the first few minutes, nothing happens. And then after a while, a few kernels start popping. This rate increases to a point in which you hear the most kernels popping. Excuse me. And then it gradually decreases again until just a kernel or two pops. In statistics, because this pattern is so pervasive, it seems to fit to call it normal, or more formally, the normal distribution. The normal distribution looks like this. Okay, it starts out with a few, and then more, and then more, and then we get to a peak, and then it declines. Okay. The normal distribution is an extremely important concept because it occurs so often in the data we collect from the natural world, as well as many of the more theoretical ideas that are foundations of statistics. This chapter explores the details of the normal distribution. Okay, the standard normal probability distribution, the shape of a normal distribution. A normal distribution is perfectly symmetric, meaning that's a mirror image. It is a mound-shaped distribution. It is commonly referred to as a normal curve or a bell curve. Okay, so why it's called a bell curve? Because when people used to ring bells, I haven't really rung a bell in a long time. They would have a handle here, and they'd have this thing called a clapper. And then it would ring the bell. This would be suspended by something, and you would ring the bell. So it's called a bell-shaped curve. The center of the normal distribution is located at the highest point of the distribution, and the measures of central tendencies are equal. Okay, note the center peak divides the data into two equal parts. Okay, so the mean is equal to the median is equal to the mode here. Okay, the mean and the median and the mode, they're all the middle. Okay, for the normal distribution. The mode, the one that occurs most, is in the middle. The average is also the middle, and the median is the middle. The middle is the middle. Okay, so it's a very nice distribution. Okay, the spread of a normal distribution. The most common way to measure the spread of a normal distribution is that with the standard deviation, or the typical distance away from the mean. Okay, the standard deviation indicates the distance from the maximum peak of the data because of the symmetry of a normal distribution. Now, if we want the average or mean, okay, of the normal distribution, and it's a population, that's mu. Okay, mu is the population. Okay, and this guy, the mean, this is the mean. X bar is just the sample, okay? But when we're talking about normal distribution, most of the times we're talking about some sort of population. Okay, so just keep in mind that the mean is the mu unless it's a sample. Okay, and then so mu would be right here. Mu would be in the middle. The standard deviation is called sigma. It's a little O with a little hat on it. Okay, it's called sigma. Okay, and that is also for the population. If we're talking about the standard deviation of the population, that's sigma. Okay, the larger the standard deviation, the more widespread this is. However, the area under the normal curve always equals 1. It always, no matter what, it is always equal to 1. I gotta go blow my nose. I'll be right back. Sneeze too much. Shush, dog. Okay, sorry about that. Okay, so again, the standard deviation is how far we deviate on average. But again, the area under this curve, the green curve, is the exact same area as under the red curve. So just keep that in mind, okay? They're both, the areas both sum to 1. Okay, so the empirical rule, okay, so let's say, what do I want to do here? Let's go back to the empirical rule for a second. Okay, let's look at a normal distribution. Okay, normal curve. Okay, and let's say that the mean is 70. The mean is 70. So mu is 70. Okay, so the mean is 70 here. And we're going to say that the standard deviation is equal to 10. Okay, so every time I go out 10, up 10 and down 10, right? So we would go up 10 and down 10. Okay, so this is plus and minus 1 standard deviation, plus and minus 1 standard deviation, right? Up 1 standard deviation from the mean and minus 1 standard deviation from the mean, right? So 60. Does that make sense? So I took 70 and I added 10. This is, we would say this is plus 1 standard deviation. Okay. So plus 1 standard deviation. And then this was minus 1 standard deviation, right? Well, the, I don't want to do that. There we go. Well, the area in between +1 standard deviation and -1 standard deviation is 68% of the total graph. This is 0.68. Okay, that's 0.68. Okay. Now, let's move on to 2 standard deviations. Okay, let's say that we're at 2 standard deviations below the mean and 2 standard deviations above the mean. Okay, so, well, this would be 50 and this would be 90, right? 2 standard deviations. So this is -2 standard deviations and +2 standard deviations. And so what amount is included in the 2 standard deviations? So for plus or minus 1 standard deviation, that equaled 68% of the graph. 68% of the graph. Because the total area is 1 underneath here, right? So the total area is 100%. Total area is equal to 1 or 100%. Okay, so plus or minus 2 standard deviations is going to be equal to 95%, 0.95. Okay, so if I go out 2 standard deviations and this whole thing, okay, includes 95% of the graph, 2 standard deviations from here to here. Okay, so now what happens if I go out 3 standard deviations? Well, 3 standard deviations. 3 standard deviations. We would be going from 40 to 100. And so 3 standard deviations. Okay, plus or minus 3 standard deviations. That's 0.997 or 99.7% of the graph. Okay, so this guy is 68% of the graph. This guy is 95% of the graph. And this guy is 99.7% of the graph. So almost the whole thing. Okay, and this was -3 standard deviations, and this is +3 standard deviations. Okay, so let's go back to this. Okay, it says the empirical rule states that the percentages of data in a normal distribution within 1, 2, and 3 standard deviations of the mean are approximately 68, 95, and 99.7. It is common to use the Greek letters sigma and mu to symbolize the standard deviation and the mean, respectively. Okay, so 68% lies in the red. Okay, 95% lies in the green. Okay, and 99.7% lies within the blue all the way to 3 standard deviations, right? Okay. Notice we can split up the percentages to obtain further information regarding the data. Right? So if going from +1 to -1 was 68%, well, if we split that in half, we get 0.68 over 2 is 0.34, which is 34%. Oh, okay. So this is 34%, and this is 34%. Okay. Interesting. Okay. What about this guy here? This was 95% here, right? 95%. Okay. So, but how are we getting these 13.5%? So we take 95% and we subtract off two 34s, right? Subtract off the middle green, and we want to know how much is left over on those tails, right? How much is over on those tails? Well, 68%, 0.68%. Okay, and 95 minus 68 is what? 0.27. So 27% is located in those tails. Okay, so 27%, but I have two of them, so I have to divide by 2. Okay, maybe I should color code this. So we have 95% minus 68% is 27% divided by 2, which is going to be 0.135 or 13.5% in these two tails. So these two tails are 13.5% each. Okay. And then what about these last ones? Well, we're going to take 99.7% or 0.997, subtract off 95%, right? To go out to 3. To go out to 3 here would have been 99.7%. Oops, where the heck did my stuff go? Come on, go back. There you go. Okay. So 99.7. Oh, what the heck, man? Stop. Don't be like that. Okay, 99.7. Let's do this in red. 99.7% minus 0.95 is equal to, I don't even know what that is. What is that? 0.997 minus 0.95. Nope, let's try that again. 0.997 minus 0.95 is 0.047. 0.047. And we have two of those, we got to divide by 2. So that's going to be 0.0235. Okay, or 2.35%. Okay, so this is 2.35%. This is 2.35%. Now, how would I get the last ones here? How would I get the last ones? Well, I would take 100%, which is the whole thing. That's the whole enchilada here. And I would subtract off that 99.7% or 0.9. I'd take 100%, which is equal to 1, minus the 0.997, which is equal to 0.003. Right, or 0.3%, and then I would divide by 2, and that would be 0.0015. So move the decimal over twice, and that gives me 0.15%. So that's what's left over here, is the 0.15%. This guy here. Maybe I'll just put that in yellow. Okay. Okay, so you can partition it like that as well. Okay, so let's revisit this. Okay, using standard deviation and mean. Okay, find the prices of peanut butter that lie within 2 and 3 standard deviations from the mean. Interpret results in context of the empirical rule. So, well, we have to find out, well, what is the mean? Okay, so they're telling us that the mean is 3.68, right? So that's what mu is, right? So, okay, plus or minus 1 standard deviation, okay, is going to be 3.68. I'm going to go 3.68 minus 1 standard deviation. That's going to be my low point. 0.26, and 3.68 plus my standard deviation, one of my standard deviations, 0.26. Okay, when I add that together, I get 3.42. okay, dollars to 3.94 dollars. And so this will include 68% of my graph. Why? Because it's plus or minus 1 standard deviation. So if I were to look at a normal curve here, right, with these values, okay, and I said that the mean was 3.68, then 68% of the graph would be contained between 3.42 and 3.94. So this would be 68% of the graph. Okay, let's try plus or minus 2 standard deviations. Okay, we could either take our original, our plus or minus 1 and then just subtract off another one. Okay, or we could just go 3.68 minus 2 times 0.26. Because we want to subtract off 2 to get the lower value. And we want to subtract off 2 to get the lower value and add 2 to get the upper value. So this is 3.68 plus 2 times 0.26. Okay, and what's that going to equal? That is going to be equal to, okay, plugging that into a calculator, you would get 3.16 and 4.20. So, and that would be 95% of the data would be in there. Okay. And then what about the last one? Plus or minus 3 standard deviations. 3.68 minus 2 or minus 3 standard deviations, 0.26. Oops. And 3.68 minus 3 standard deviations. Okay, so this is plugging that into the calculator, I get 2.90 and 4.46. And this would include 99.7% of the data. Okay. Okay. Let's talk about what a z-score is. A z-score is how far away, how many standard deviations away from the mean we are. Okay, z-score for particular data is the number of standard deviations away from the mean. Given by the formula, z is equal to the data point minus the mean over the standard deviation. Okay, so z is equal to x minus mu over sigma. Okay, this is called my z-score, where x is the data value. Okay, the mean test score for statistics class was 82. Okay, so the mean was 82. Okay, with a standard deviation of 7. Okay, if a grade A is 93 points, what is the z-score for an A on the test? So the z-score for this data point, 93. Okay, 93 minus, okay, mu, so that's the formula here is x minus mu over sigma. So x is 93 minus mu, which is 82, over sigma, which is 7. Okay, so this comes out to be 93 minus 82. 11 divided by 7 is about 1.57. Okay, so it's roughly 1.57 standard deviations above the mean. Now, why is it, how do we know it's above the mean? Well, it's because it comes out as a positive number, okay? The z-score for the mean is 0, okay? So the z-score for the mean is 0, and it kind of looks like this. Okay, if I have my normal curve, okay, this is 0 standard deviations away. This is 1, this is 2, right? This is 3, this is -1, -2, -3. And again, from -1 to +1, that's your 68%. Okay, and then 2 and 3 and whatever. So we are 1.57 standard deviations above. Why? Because it's a +1. Where would we be located on this graph? We'd be located about here. Okay, that is where a 93 would be located. This is a 93 if the mean is 82. So the z-score is a way to standardize all normal curves. So it's a way to compare apples to apples. If I wanted to compare heights of, heights of girls to heights of boys, okay, I could standardize it using this z-score, because the girl height might look like this, the boy height might look like this, okay, but I could standardize it and find out, what percentage of boys are bigger than something and what percentage of girls are taller than something. And I could say, well, in their relative, in their relativeness, get the right color here. In their relative group, not overall, but in their relative group is a, say, 60-inch girl. Is that, what percentage of 60-inch girls compared to what percent of, I don't know, 66-inch boys? Okay, so, right, so would a 60-inch girl be shorter comparative to her group, or would a 66-inch boy be shorter comparative to his group? We can compare using z-scores. Okay, because if I were to find this value, if I were to find the mean here, if I were to find the mean here as a z-score, that's 0. And if I were to find the mean here in this group, that's also 0. So it's a way to standardize no matter what group you're in, okay? So we could compare things. Okay, so a student Pat, okay, student Pat was done taking student Pat was done taking midterms. She received a grade of 82 on her statistics exam. Okay, where the mean grade was 74. So the average grade was 74. So the mean grade was 74. Okay. Oh, she received a grade of 82. So Pat, right? Pat received her grade was equal to 82, but the mean in the class was 74, and the standard deviation for Pat was 12. Okay, in her statistics exam. So this is stats. In her stats exam, boom. Okay, she then took a biology exam. Okay, so in bio, let me use a different color. Okay, in biology, she received a 72, but the mean grade was 65. So maybe that was a harder exam because the average was lower. And the standard deviation, how spread out they were, was 10. Okay, so they're about the same spread out. Okay, same curve overall. Okay, and then lastly, she received a grade of 91 on her kayaking exam. Who takes kayaking? I want to take that. Go hang out with the sea lions. Okay, so kayaking. Okay, what was her grade? Her grade was 91, of course. I mean, what do you have to do? Just paddle in a circle? I mean, come on. How hard is that? On the kayak exam, the mean grade was 88. Okay, and the standard deviation was 6. Okay, so let me take a look at what these graphs are kind of looking like. Okay, so we have this normal distribution. The mean is at 74. Okay, and the standard deviation is 12. So the next one would be at plus 12, and this would be minus 12. Okay, what about the next one? The next one, oops. The next one is fairly similar, except it would be down lower. Okay, this would be at 65 would be the mean. Okay, the mean would be 65, and the first and second up one standard deviation would be plus 10 and minus 10. So they're about the same spread, but lower mean, right? So it's almost like I took the top one and moved it over. Okay, moved it less. Okay, and then what's the last one here going to look like? Well, that one's kind of interesting because the mean was 88. The mean was 88. Oops, way high. The mean was 88, but it didn't have much spread. So the mean here is 88. So the mean was really high, and the spread not so much. So this would be plus or minus 6, minus 6 and plus 6. So you see how it's much taller and narrower than the other two. Still has the same area underneath. Still has the same amount of area. Okay, so I want to know, how did she do relative to those classes, right? Is an 88, you know, she got a 91 out of 8. She got a 91 in kayaking, but relative to the rest of the class, was that necessarily, and you know, how far away from the standard, from the mean was that, right? How far away? Maybe it wasn't too far. We'll see what happens here. Okay, so let's find the z-scores for each of these and try to compare and see which one did she do relatively best in. Okay, which class was she relatively better than the other students? Okay, so in the stats class, we want the z-score to be equal to, z-score to be equal to, okay, x minus mu over sigma. Okay, so x is the grade that we got, she got, he got, I don't know, they got. Why would we just say they? I'm going to assume that Pat is a she. Oh, it says she here. Okay, good. I have to be careful with my pronouns then. Okay, it says she. There you go. Perfect. Okay, so 82 minus, okay, minus 74 over 12. Okay, so 82 minus 74 over 12. Okay, and so plug that in. What's 82 minus 74? That's 8, so this is 8 over 12. Which is what, 2 over 3? So this is 0.6 forever. Yep. Okay, so that was for the stats class. So the biology class, z-score is x minus mu over sigma, which is going to be 72 minus 65. I mean, in all three classes, she got better than the average, so that's good. Good job, Pat. Okay, but comparatively to each exam, right? Because some exams could be harder than others. How did she do relative to the rest of the class? Okay, I don't know. So this is 72, this is 7 over 10, which is 0.7. Okay, so she did a little bit better in biology than stats. What about kayaking? How did kayaking fare here? Okay, so kayaking, we've got the z-score as x minus mu over sigma, which is going to be equal to, what you have here, 91 minus 88 over 6. Okay, so what is that? 91, that's, I don't know what that is. That's 3. So 3, she deviated 3 away from 6, which is 0.5. So again, what's happening here? Well, if we standardized all of these scores, we'd get them on one standardized graph, and the standardized graph would have 0 in the middle, and it would have 1, 2. I can never get the tails right on these things. There, better. Okay. Oh my gosh, bring it back. Walk it back. Okay, so this is -1, -2, -3. Okay, and so we're saying that the z-score for the statistics class was at 0.6. Okay, so maybe right here. Z-score for her was 0.6. It was above the mean. We already knew that she scored above the mean because it's positive. Okay, so positive means that you're in, this area here. Okay, and then the z-score for the biology test was 0.7. That's better. Okay, even further above the mean. Okay, and then the kayaking was 0.5, so below. So which one did she score relatively better on the biology test? Had the better score relative to the other exams. Okay. So the biology class had the better z-score there. Okay, we're kind of coming down to the end here. So what do we got? A couple more weeks? So yeah. Next week is Thanksgiving week. Okay. Okay, one thing that I should hand out at this point is the handout. So I will post this. I'll post this on oh, me, I'm just staying home. Just me and my wife and my 2 kids staying home. It's a good excuse to not have to deal with my sister-in-law because nobody likes her. So COVID was a good excuse to not have to deal with her family. So is that bad? Is that bad of me to say? Like, it's just nobody likes her, except for everybody that does like her. you know, have you ever met anybody like that? Like everybody likes them, but nobody likes them because they're just completely fake people, right? Like they have their followers. She has a lot of minions, but if you really got to know this person, you wouldn't like her so much because she looks down on everybody other than herself. So it's kind of like Donald Trump in a way, right? It's like, I mean, kind of that narcissistic mentality. Like, oh, well, he thinks everybody loves him. She thinks everybody loves her, but really it's just because she's judging everyone else. And since she judges me the most of anybody in the family, I don't want to be around her. So, you know, like she likes me the least of anybody. So I'm just like, screw it. So what I did was I ordered a turkey dinner. No, not a turkey dinner. I ordered a ham dinner with all of the fixings from Mimi's Cafe, and they're going to have it catered, delivered the day before Thanksgiving. So yeah. So is anybody going anywhere? Everybody staying home this year? I'm just trying to be safe and not have to deal with my sister-in-law. So it's the best idea for me. Okay, so let me show you something real quick, and then we'll call it a day here. Okay, so on Canvas, okay, on Canvas, it has something called Z-scores. Okay, Z-scores. So keep that in mind. Okay, and if we can really learn this stuff and know it and practice it well, then okay. If we go to module 13, I think that's this week, right? Okay, so the Z-score table, you're really going to need to know how to access this on Monday. Okay, so this Z-score, these are the percentages, and the Z values are how far, okay, how many standard deviations away from the mean. Okay, and these are all the values that have already been calculated for us. Oh, they're already calculated. You know, like that 95%. Well, this is what would it be if it was 0.1 standard deviations away, and 0.2 standard deviations away, and 0.3 standard deviations away, and 0.4. So they have one standard deviation away, which is nice. Okay, what if it was 1.1, right? Or 1.01, right? So this is a table, and I'll show you how to read it, but just know how to access it. Okay, you need to know how to access it. It says, I think it even says here, students, below is the Z-score table. You can refer to, download, and print off if you like. So I would highly encourage you to print this off if you have a printer and just have it handy, because you're going to be able to use this on the next exam, okay, which is coming up here in like 2 weeks. So like a week and a half. Okay, so we're nearing the end of the semester, and you're going to want to be very familiar with the Z-score table. Okay. Okay, so it's basically how much of this area above. Okay, let's zoom in here. The table gives a probability, because we're going to talk about the area, and the area is the probability. Just a little spoiler alert there, that we're going to talk about probabilities next, and the areas are the probabilities. It's the same thing. So the area above the mean is given by this table. So a z-score of 0.1 would be a z-score of 0.1 here. And the second row would be 0.03983. Okay. So a z-score of 1 would be 34%, just like we had said, right? 34%. And it gives extra accuracy here. 34%. Okay. That's kind of cool. Okay, because if you go back to the notes, right? So a z-score of above 1 was 34%, right? So this here was 34%. So I would, again, try to familiarize yourself with this. If you are able to familiarize yourself, then the lecture will go much faster. Okay, and we can get through this material a lot quicker, which will be good because next week may be a pretty hectic week for a lot of us. Okay.
Is there class Monday and Wednesday? Yes, right? For this class specifically?
There is supposed to be class on Wednesday, yes.
Okay, just wanted to make sure. It's because at our school, we have no classes, and I know this is different. This is college, and I want to make sure.
Yeah. Oh, your school is closed on Wednesday of next week?
No, we're closed for the whole week. We have a Thanksgiving week or break.
Oh, you're off for the whole week. Okay.
Yeah.
So no, we're scheduled to meet Monday and Wednesday.
Oh, okay, I'm good. I just wanted to make sure for this class because my law class is having class too, and I just want to make sure for this too.
When do your guys' semester end?
Well, for this class, I mean for Somali,
Yeah.
I think it's like before Thanksgiving, I mean, before Christmas week, halfway through December.
You guys,
Yeah, like
you guys probably go an extra week than we do.
Yeah.
Yeah, right. So okay. Because we're done the 9th, just to let you know. We're done the 9th of December in this class.
Okay, I'm gonna write that down too.
Keep that in mind. So you probably go an extra week to the 16th. Okay. Okay, I'll see you guys on Monday. Oh, make sure that you turn in your chapter 10 worksheet. That is due. Okay, hopefully you already finished it. Hopefully you already finished it. But I can't hear you. What? Maybe you can type it in the chat box.
Is it?
I think your internet is slow. The due date, that's Sunday. Sunday at midnight for the chapter 10 worksheet. Okay. Okay. All the other homework for this week is due by 9. Okay. Thanks. Yeah, make sure you turn this in. Don't screw yourself over at the last step here. You want to finish strong in this class. Okay, so you can pass. Make sure you're passing. Okay, bye. Oh, Liliana's here. Okay, good. Go back. Go back. Assignments. Attendance.